Welcome to episode 36, 37, episode 37, my bad, of the Swift and SwiftUI Learnalong. This is your host, me, and this is where we learn Swift the real way of learning, through scores of redundant and monotonous, mind-numbing repetition. And reading books, you know what I'm saying? So, what's going on here? You don't have permission to save the file. Oh, what, brother? Okay, I got some issue here. That's okay. Oh, I moved my disk. That's right, brother. That's okay. That one's my fault. Yeah, so anyway, this is where we learn Swift and SwiftUI. And eventually, once we're done with this, soon, that'll be very soon, this will turn into an iOS and macOS and iPadOS Learnalong, still with, ooh, excuse me. Went back to puberty for a sec. So there's going to be a lot of streaming, basically. So if you are just getting here, just know that the entire Swift Learnalong has been, oh, that's why it's a different spot, isn't it? The whole thing has been streamed effectively. So after we get through this, we're going to jump into the platforms, so we can actually learn the platforms as well. And it'll be much of the same fashion. So I call it fly on the wall learning, as I have effectively or affectionately labeled it. So there's not a ton of interaction. Oh, what is happening? Anyway, you're watching a guy learn raw and in real time. So that's the premise here. And I hope that can still be helpful in the sense that it's cathartic for me. So it helps me stay on top of my game in terms of just being consistent, you know? Like, even if I just know that there's at least one person out there that might be getting value from it, that helps me, okay? But also know, too, I'm stalling hard, by the way, because I'm just trying to get this. I moved my project files to to the computer's drive, the internal drive, but now it seems like it doesn't want to do it. What is this? Protocol. Well, actually, I don't even know that I need the old one open. I guess we'll just open Xcode. How about that? Yeah, but anyway, so I'm building an app. I have an intention to build an app that is really geared towards, I'm not sure what to call this thing. Oh wait, not a project. I need a playground. It's really going to be geared towards anybody that has, a standing ERP system and manages physical inventory, specifically around the concept of MRP, material resource planning, if you ever heard of it. But I won't bore you guys with the details just yet. But there is I'm not sure if this is, we'll just call this memory management. But there is an intention, my point in saying all this, there's an intention here to monetize what we're building, so there should be no misconceptions there. But at the same time, I'm not trying to monetize you guys in that sense. It's literally just raw learning. Where the F did I guess that's where I did it. I mean, shucks. Yeah, just get me in the editor, brother. Shoot. It's very finicky about like files of the same name being moved. Whatever. I'm not going to bitch about it. Okay, so the good thing is allergies, man, and they're out there cutting all that damn grass. This freaking sucks. Okay, but anyway, I say all that to say, make sure you stick around, follow along, because I'm going to be doing this for quite some time. It's actually really been great for me because I've learned a lot more in a much shorter time span, and it's undeniable in the sense that, like, when I look at my pace, it's just so much faster. If you, like in my case, I created the stream to help me, to motivate myself. So whatever you can do around that, I would recommend doing, just to kind of hedge against your own weaknesses. That's kind of how I see it, because I know I can do the things. It's the consistency. It's the ability to come back, do it again, do it again, and not necessarily master it, right? I mean, we're just reading the book. We don't have the practical, applicable knowledge yet, but we're going to get it. But at the same time, you do need the foundation. So, I mean, I like the book style learning. I know people preach project learning, book learn. I think you got to do both to a certain extent. I think more than likely after, like, Swift is a pretty big language, as we've seen. Lots of features, lots of great features. And so I would think that after learning something like, Swift or C++ or Rust or, any language that just has like a bunch of stuff going on, I would imagine that subsequent languages, irregardless of the paradigm, other than maybe like pure functional, but why would you do that to yourself? It becomes easier, right? But I think at some point when it comes to book/project learning and you're trying to decide, I just think it's goofy to sit down and try and write a project and you don't know the foundational aspects of programming yet. I think if you do, then the project learning makes sense. Yeah, but I'm not there quite yet. And the book style, I actually really like this book, so I'll quit gushing on it and I'll just get started, I swear, after one more thing, because I want to highlight the fact that, let me just show you guys. I've showed you guys before. I'm just going to show you one more time. No, not that. This is just my Kindle books, okay? There's probably another 100 from, disparate locations, but I mean, these are all programming books, brother. And I can tell you that there's a pretty stark contrast with I'd say the only exception being like the Manning, if you know what Manning is, Manning Publishing, the bookstore, online bookstore. I'd say they're the only exception. But out of all of these books and out of all of these companies that write books, there's a pretty stark disparity to me. There's a pretty big contrast between the quality of these big nerd ranch guides. So like right now we're doing the Swift one, but they have others. Like the next book that we're going to do is this one here. I just saw it. Where'd it go? Right here. The Big Nerd Ranch Guide on iOS programming, the Apple platforms. But just their style, the way that they explain things thoroughly, give you the examples, and then explain what the code is doing after the fact has been, I mean, it sounds silly to say that's a revelation. But I think we forget, I think YouTube has, not just YouTube, but, the free and open access to all this information online. That's great, true, that is good. But even with me, it's applicable to me too. I just think I'm a bit of the exception because I'm not teaching you from my head. I'm teaching you from what I have deemed to be a reputable source, right? So it's a little different. But I think generally speaking, when you take tutorials from people online or whatever, we have to remember they're not professional educators. Not that you have to be a good teacher, but it's a lot more rare that you're going to have a person that is not formally trained to teach anybody. It can become difficult to learn from those people. I think we forget that a little bit, because I certainly did. And I'm saying that because for two reasons. One, for probably the past 3 years, I've been consuming educational material, so I can speak on this. I know what I'm talking about in that way, in terms of the wild swings in quality. They're all pretty expensive, but they all have wild swings in quality. So I'm just saying, I think we've forgotten a little bit that teaching is a profession too, and it's a skill unto itself. Okay. Last thing, I swear this is the last thing. I just want to say this real quick. If you want to see what I'm talking about, I can give you a great example. And I bet you it won't take very long for you to agree with me, I'll say. And it has nothing to do with me. It's an example. OCaml course. Hopefully that finds it. Yeah, this guy right here. We're not going to learn OCaml, don't worry. But I'm just telling you, if you want to learn functional programming and OCaml, or even just get a taste of it, or to prove my point, if you just want to see what a good teacher looks like, sounds like, acts like, just come watch this guy's playlist. He did this, it's free online. This was a computer science course. They're using OCaml to teach it. But this dude, this was during COVID. It got so popular, he did all of these videos. I think there's like 250, something like that. OCaml online course. Yeah, it's linked here somewhere. Who's texting me? Oh, GoDaddy? Why is GoDaddy texting me? But yeah, I just want to show you this real quick because well, whatever, it doesn't matter. The point is, these are the videos. There's also a book. There's an online book, and all of these videos, these same videos, so it doesn't really matter. I'm sure in the video he'll give you the link to the book if you want to check it out. But 250 videos, all broken up section by section. There's classroom style. He shows you the actual code. If you're curious what a great teacher sounds like, looks like, acts like, come watch this dude, and I guarantee you'll be a little bit shocked, just in terms of the stark contrast. So yeah, we forget that a little bit. Teaching is a profession and a skill, and I say all that to say it. I mean, it definitely matters. Your teachers matter. Where you spend your time matters, and this is a great fucking, pardon my French, this is a great darn tootin' piece of literature right here. Great job, Big Nerd Ranch. Okay, now then, yesterday we covered this result type mainly. We spent a lot of time looking at this result type, and the result type, I won't dig into it too far because we did a whole hell of a lot of digging yesterday. We added some new entries to our board, mainly about self, a lot of this self stuff and a lot of the result type. But that was all yesterday. Now, memory management. And I think this is, let's look at the index. We're almost through. Yeah, this is 1, 2, 3 more chapters, and then we get into writing some apps, brother. Hell yeah, brother. And memory management, I've been very curious about this because I think I've leveled out. I think for a while I was struggling with the difference, probably up until a few months ago, between a runtime, like something having a runtime like Go, a runtime like Swift, which both do have runtimes. I was conflating that idea with the garbage collector. So in Go's case, even though Go is pretty fast, I mean, that's not really an argument. I mean, but pretty fast too. Like, how do you quantify that? But just remember things like CockroachDB, a distributed ACID compliant database, is written in Go. Docker is written in Go. Yeah, so it's that fast. It's fast enough to support those technologies. So keep that in mind. So Go is it ain't no slouch. No, but that being said, it has a garbage collector. Now this automatic reference counting, this ARC style memory management, I've only heard, the only other place I've even seen it mentioned, I have no idea how it works. We're about to find out, but I've only ever seen it mentioned in NIM, the other programming language that I encountered it with, NIM, N-I-M. So I'm curious to see how this differs, what that means. Is there Because if you have a garbage collector like Go, even if it is fast, there are moments where it literally stops everything. And from an end user perspective, you can think of it as being representative. If you've ever used, been working in a big program for a long time, and then the longer and longer it runs, every now and again it starts to skip, like little skipping frames. That's the garbage collector working. So with Swift not having that, I'm curious where that kind of manifests, because I've really heard a lot of things kind of all over the place on Swift performance. So let's check it out. So memory management and Arc. Oh snap, I didn't even got my background music on, brother. Just got to yapping. Let me fix that. Okay, yeah, it's on. Very quiet. Okay. Chapter 24, Memory Management in Arc. That's my narrator voice. This chapter brings together several topics from earlier in the book, especially Chapter 13 on closures and Chapter 15 on structs and classes. Yeah. That all relate to managing memory used by your programs. All computer programs use memory, and most use memory dynamically. As a program runs, it allocates and deallocates memory as needed. An important role of any memory management system is managing object lifetimes. In particular, ensuring that memory is not deallocated too soon or too late. For example, using programming languages use different tools to manage manage memory. Java, for example, uses a garbage collector. Swift uses reference counting to manage object lifetimes. In this chapter, you will investigate how the reference counting system works and learn what you can do to avoid memory leaks. Okay. Memory allocation. The allocation and deallocation of memory for value types, enumerations, and structures would be those two things that are value types. Remember that? Is handled for you. Okay, so the allocation and deallocation of memory for value types is handled for you. So we're not doing if you've ever written any C, they have the free and the defer and free, malloc and alloc, something like that. I did it very briefly. It actually is not that complicated. It's just I can see, it's obvious how as more code, the bigger the code base, that could be pretty wily. But unto itself, as a concept, with how you do it in the C code, it's really, you could understand it, I think, after. You could learn the syntax in a couple of hours. I think you could even understand it maybe in a week. Now, getting good at rolling it into production, I have no idea. 20 years? I don't know how long it takes. But where were we? Property creates it. Yeah, okay. When you create a variable to store an instance of a value type, an appropriate amount of memory is automatically set aside for your instance, and your variable contains the entire value. Yeah, so I think this will be helpful, because if you don't know at all what they're talking about, it's very esoteric. It's what? Please provide an example of C code where manual memory and alloc are used. Yeah, so just so we can, not that I can talk you all the way through it, but just so you can literally see that in a top-down fashion, what's going on with the code. Where's the code? There we go. Okay, so, all right, so not Swift code. I don't want anyone to swing by here, see this, and then think, oh shit, Swift is trash. No, relax, brother. So, but where did it? I just saw it. Yeah. So see, you can dynamically allocate memory, but you literally have to control it, which is pretty trippy and pretty cool. It's not all that complicated, but you can see how you just have to keep track of many things. So dynamically allocate memory for n integers. I think, what is the asterisk? It's a pointer. So an integer, a pointer to an array equals, oh God. Anyway, this malloc is the keyword, the operator for allocation. So I mean, after this ran, you would be, putting something into memory, and then it just sits there until you free it down here. See that there? So it seems pretty simple. Like I said, you allocate it, do something with it, and then when you're done with it, you free it. So that one simple concept, it's coming down the line, and then it gets allocated, runs this conditional, another conditional, print something. I'm pointing, like you can see where I'm pointing. Print something, printf, and then return that memory. You don't need it no more. So the concept is simple. Scaling it is very complex, and thus we have many other languages, right? Okay, so I'm gonna leave that there, but that's not Swift code, just FYI. All right, so we understand that now. So generally speaking, that's what we're talking about here, except, well, in terms of allocation, that's what we're talking about. But with Swift, we're not doing all that, of course. It's using some other algorithm that they've named reference counting to handle this for us. Okay, so now, okay, when you create a variable to store an instance of a value type, an appropriate amount of memory is automatically set aside for your instance, and your variable contains the entire value. Anything you do to pass the instance around, including passing it to a function and storing it in a property, creates a copy of the instance. When a variable containing a value type instance is destroyed, such as when a function that creates one returns, when a variable containing a value type instance is destroyed. Okay, yeah, so if we write a function that has one of those ad hoc variables, like a guard let, like one of those statements that we saw, guard let if, there's some kind of condition where if it's true, you want to store that value, do something with it, but by the time the function runs, you're already done with it. So that's what they're talking about here. So that would be its lifetime, within the time that function takes to execute. Each copy lives an independent lifetime and is automatically destroyed when the variable holding it goes away. You do not have to do anything to manage memory of value types. Hot dog. Okay, so that's good. Value types, of course, again, being the enums. Value types, enums, and structs, which even C has structs. It's been around a hot minute. And then we have the others, reference types. Well, it's really type, because that's classes. Class, whatever. So bear that in mind. So when they say value types, in your head, you can just think, okay, they're talking about enums or structs. All right. You will need to know a little more about memory management of reference types, specifically class instances. When you create a new class instance, memory is allocated for the instance to use, just as it is for value type. The difference is in what happens when you pass the class instance around. Right, and so to this point, my understanding is that with classes, you're you're not making copies. When you create an instance, you're creating a reference to the class in memory. Yeah. So just generally speaking, and that's why I was saying that Swift's use of final class, which is just a way to use classes but restrict having any subclasses, would probably be my go-to if I ever needed to optimize, because on your value types, you're making copies everywhere. And so if you're dealing with big chunks of data, that obviously can slow down your program. So we may encounter that. I'm sure we will. And it'll be fun. So as you learned in Chapter 18, on value and reference types, passing a class instance to a function or storing it in a property creates an additional reference to the same memory. Yeah. Rather than copying the instance itself. Yeah. So like, let's try to art that out a little bit. So meaning, if we take, it's like this is a class. Oh, why did it disappear? Yeah, so you'd have a class, and then that would just exist in memory somewhere, and then anytime that we create an instance by writing like var something equals, and then class, so that would mean something is equal to an instance of whatever class, right? When we do that and it creates that new object, this thingamabob, so let's say the square is the main class, and here's our instance. And so instead of it being a copy, this would just be a reference to maybe use a different color there. Back to the master. So in all reality, the actual object, there's only like one thing representing it in memory. Everything else, like the var something, anywhere that we use this, is going back to that single place in memory to get the properties or whatever you wrote in it that you need to do. Hopefully that makes some sense. But it's just it's a pointer. It's saying like, hey, it's over there. It's not actually here, brother. It's over there. Oh, you need to read me? I'm not actually here. I'm over there. It's like a redirect, kind of. But the issue is when you take this, like this reference, this object, var something, then you have like 15 others, and they're all kind of looking back at that same class, and you get into some funky business. I mean, trust me. But so that's what we're talking about, right? You would need to learn more about memory management of reference type. Oh, we read that. As you learn in Chapter 18 on value and reference types, passing a class instance to a function or storing it in a property creates an additional reference to the same memory, rather than copying the instance itself. So that's what we just looked at. Having multiple references to the same memory means that when any one of them changes the class instance, that change is apparent through any of its references. Yeah. Which was always our problem in Fox Pro land. So effing annoying. That changes apparent through error. What's interesting too? Obviously I'm not going to name any names, but it's interesting to think now, hearing more about these OOP issues. When I was working with it, I was writing the SQL for it, but I was not touching the actual application code. The app code, if it needed to do something with my domain, which was the data side, I would just give them the stored procedures and they would just plug that into their application code. But there was still we were trying to eliminate it, but there was still quite a bit of business logic in the application code itself, which was always the problem. It was, I don't know how it got so, but yeah, it can be a real pain tracking that down, especially when you have classes and references pointing all over the place, all over creation. It's crazy. This distinction raises an important question. When should a class instance deallocate? The answer is when all the references to it are gone. Every class instance knows its reference count. The number of existing references to the instance. The instance remains allocated as long as its reference count is greater than 0. Okay. So in my head, so every class knows its reference count. So that would mean something along the lines of like boom, boom, boom. I create and let's just say those are all like var some things, right? All three of them are separate. Equal a class. And then this is of course class, the actual thingamabob. And so it keeps its reference count. That's interesting. So it knows, I guess, on creation of an instance, I guess it'd be the other way around. When you create it or when you call it, it would just go update that little counter, something like that. But that's what I'm seeing. Wait, what's going on here? Elect control. Oh, good old macOS securities. Okay. Nothing's happening. Is it doing it for my whole? Sure is. Okay. My bad. It's just not going to work, and that's fine. I give up. All right, so where were we? The distinction raises an important question. When should... Oh, yeah, nobody just remember that. The instance remains allocated as long as its reference count is greater than 0. When the last reference to an instance is destroyed and the instance's reference count becomes 0, the system deallocates the instance and runs its dinit method. Oh yeah, I forgot about dinit. Weird. Which dinit we learned is of course only required for reference types. Yeah. The Swift compiler handles incrementing and decrementing instance reference counts so that you do not have to. Sweet. This automatic reference counting automatic reference counting feature helps ensure the class instances are destroyed at the correct time. However, logic errors in your program can cause objects to not deallocate when you are done with them. This is called a memory leak, and in this chapter you will learn how to prevent such errors by instructing the compiler to use variant memory management rules where appropriate. Interesting, yeah. Okay. To demonstrate these features, you're going to build a small program to model interacting with a storage vault. Oh, nice. That's really cool. Create a new macOS command line tool. Name cyclical assets. Okay. So I guess we don't need that there, guy. And then create a new macOS command line. Oh, not a playground. Okay, so we're back to project. Command line tool, macOS. And call it cyclical. assets. And Swift language. Yep. Sure. Yeah, when I look at Xcode, I'm still very I don't know what the word is. Discombobulated? Lost? But that would make sense because we not spend a ton of time digging into the features, but we will in the next book, so that's fine. I'm just saying, yeah, it's a lot. I mean, it's very aptly, you know. Nothing wrong with big interfaces. It's just different. The Swift compiler handles incrementing. Okay, cyclical assets. All right, so what's next? Strong reference cycles. To start, you will define the types you will be interacting with, vault and asset. You will create one vault and multiple assets to put into the vault, and then you will observe how your code affects their lifetimes. You are going to create a new file to model your vault. First, in the project navigator on the left side, okay. On the left side, click the yellow cyclical assets folder. I don't have a yellow folder, but I have a gray folder. Hopefully that works. Why isn't it yellow? Why is it all? I gotta download those first in your project. This will ensure that the file appears in the correct location in your project. Okay. I mean, that makes sense because the only default file is the main Swift file, which is in the project directory. So, okay. And create a new Swift file, which is control N, right? Yeah. Swift file, yes. And next, what do you want me to call it? Vault. Vault Swift cyclical assets. Oh yeah. Okay. And import foundation. Wait, so how do I think control 0, I hope? No, that's not how you do that. How do you... Command 1. Hide navigator. Oh, it's in Command and J. Hide navigator. That's not what that did. Is it 0? Oh, okay. Command 0. Ah, thank goodness. All right. And then J, Command J to focus, move focus to the editor. I like that too. That's always a big pain in the ass. Okay, we got that part. All right. Class, vault. Let number, so a constant name number of type integer. And we need an initializer. So one parameter called number of type integer. Makes sense. And little self, so self to reference the instance we're creating, self-referencing. So self.number, so this property up here that's in the class vault, we want to populate with the number that gets passed in when we initialize an instance of vault. Therefore, self number equals number, our parameter. Well, that's not right. it equals the argument, not the parameter. Otherwise, it would just be a string. Okay, so then d init, we have to. I want to say this was optional, having a d init, so you would just add it if you wanted it to exit a particular way, or deinitialize with some behavior other than the default. Self, so escape character, string interpolation, self, just self. Oh, so it'll, okay, the instance name, whatever the variable name is, it'll capture, and then it'll say that is being deallocated, and print that to the console. Okay, and then we're writing an extension to the class we just created, Vault, and we're saying with this syntax, the colon custom, this is a Swift standard library protocol. So we're saying that through this extension, wait, okay, so you can do that. So normally if we would have written this up here, like this custom, so that's saying that we want the class Vault to conform to the custom string convertible protocol, right? Oh my gosh, must have been mouth breathing last night. My throat is tore up from the flow up. All right, but I'm not sure if that's what that means, but we're gonna find out, aren't we? But that's what that would normally mean. So it's a placeholder. But yeah, so for now, we'll assume that we're saying we want, via the extension, Vault to conform to custom string convertible. And in order to conform to custom string convertible, we know, because we've seen the code before, the requirement of said conformance is to have a property called description. It needs to be of type string, and it needs to be a readable value. And so that's what we're doing here. Return Vault escape character string interpolation number. Okay. Yeah, that's it. Okay. The Vault class has a single property which you set in its initializer. It conforms to the custom string convertible protocol by implementing the description computed property in an extension. Okay, so that is the same. So whether through an extension or directly, it carries the same weight. Well, let me just ask real quick, because I don't want to go too far off the reservation, but I need to know how to think about it. I need to know in Swift, in SwiftLang, is telling, well, in SwiftLang, when defining a class, example, is defining conformance to a protocol. Defining conformance to a protocol. That's what I should have said. When defining a class extension, Control E. For example, is defining conformance to a protocol. That's a terrible question. What am I trying to say? I'm trying to say, in Swift, if I conform to a protocol via an extension to a class, versus conforming to the protocol directly on the class definition itself. Is it the same net effect? There we go. That is exactly what I wanted to ask it. It's thinking. See, look at that bubble go. It's a hard one. There we go. In Swift, conforming to a or my internet's slow. Conforming to a protocol via an extension to a class and conforming to the protocol directly. Oh, Jesus. Oh my gosh. Hold on. Can achieve the same net effect in many cases, but there are important differences to be aware of. Okay. But generally speaking, seems about the same. Okay, so we'll let the book tell us. I was just curious in general, so we won't go too far off the reservation. But I will go to the bathroom, so I need to have a quick intermission, if you don't mind, guys. It won't take too long. Let's see. Nature calls. Well, I mean, what can you do? BRB at... This won't take long. Let's see. 2 minutes, 12. Carry the 4, 3. Let's come back. At 12:05 p. Go buy in a flash. No worries. We'll be back. Got a few hours coming at you. So, yeah, be right back. Sorry I'm late, brother. God dang. I had to take care of something. Paya. Okay. But the view count counts 0 viewers, so that's actually a good thing, because yeah, sorry about that. You know, I just feel bad when I hate being late. I hate being a late mother effer. It's one of the worst qualities. But what can you do? Estimating time, one of the hardest things to do. All right, strong reference cycles. Actually, let me go ahead and chug this, brother, while no one's watching. Jared, make sure you cut this out in post, brother. Come on, Joe. Come through, brother. Stop fucking running. All right. Now. Strong reference cycles. To start, you will define the types. To start, you will... Hold on. Because I really always knew that my little crime would be cold. That's why I got a heater for your... Probably shouldn't say that. Strong reference. Yeah, okay. So strong reference cycles. To start, you will define the types that will be interacting with the vault. Okay, we did that. You got the extension. Yeah, return. Okay. The vault class has a single property. We see here, which is number. Single property. Which we set in its initializer. It conforms to the custom string convertible protocol by implementing the description computed property in an extension. Yes, that's right. So in the protocol itself, we can't have... Oh, no, that's not... Doesn't really apply. Return vault. You add an implementation of D in it so you can see when a vault is being deallocated. That is, when its memory is being reclaimed because its reference count has dropped to 0. Okay. Quickly. Let's go back and see. Inheritance. Page 413. Deinitialization is part of the process of removing instance of a class from memory. In Swift, a deinitializer provides an opportunity to do any final maintenance before the instance is deallocated. It is called automatically immediately prior to the removal of an instance from memory. Oh, okay. If the class is a subclass, then this will execute next and up the chain before the instance's deallocation. A class can only have one deinitializer. That's what I was looking for, the rules, really. Deinitializers are written with D in it. They do not use the func keyword or an argument list, as they are not like methods. You cannot call them directly. Let's see a deinitializer in action. Okay, so only one. One per class. Okay. All right. All right. 600 strong reference. How do I get rid of that blue? Oh, right there. is it doing that? Oh, Kindle, how to get rid of that fucking blue square, dude? What is that? Continue scrolling. Well, it's gone now. Okay. 2.0. In main Swift, define a class whose single method will be where you do the rest of your work, and create a vault in it. Okay, in the main file. So from here, let's learn Xcode too. So if I hit Control 0, no, not O, damn it. Control 0. But how do I switch? I want to know how to do it with the keyboard. Navigator, project, command 1. Oh, so 0 toggles 1 puts me in the project, and J puts me back. So expand, and then 1 to get over there. Hell yeah, brother. And then I can, okay. Then I can close this. And I'm back here automatically. All right, perfect. Cool. So then create a vault in it. Import foundation. Class simulation. Func. So this is a method, no arguments. A method under the type simulation. We create this constant, let vault 13, valut, let vault 13 equal vault. So this is from our vault file. So that's where that type is coming from. Our single parameter of number, we pass in the argument 13, and then we print created vault 13. Okay. Then we create an instance of it. Yeah, let simulation, try not to yawn and sneeze. There's too many bodily functions trying to go off right now. All right, let simulation equal an instance of simulation. Oh, and then simulation run. Oh, command shift. Oh, that doesn't run in the, okay. It's command R in project. Different from the playground. Okay, the run method of the simulation class is where goddamn frog in my throat. The run method of the simulation class is where all your experimentation will happen. You might be wondering why you are using this method instead of just working at the top level of main Swift like you did with Monster Town. You did this for two reasons. First, to define a scope. Which you first learned about in chapter 12 on functions. Scopes, as you might recall, are defined by pairs of braces. Functions, enclosures, conditionals, loops, and do catch blocks all define scopes where their work is done. Okay. Variables defined inside a scope, such as vault 13, defined within run scope, are reclaimed when that scope ends at the closing bracket. Aquí. Func run, or really here, yeah. If the variable contained a value type instance, the end of the enclosing scope is where the instance is deallocated. Okay, so if that was an enum or a struct, it would just get deallocated after it runs that, and then it's done. But that's only for value type instances. If the variable contained a reference, the end of the enclosing scope is where the instance's reference count is decremented. Oh, that's okay. I see. Possibly leading to its deallocation, but not absolutely. What is GoDaddy trying to get me to? What do you want, dude? Come on, friend. Okay. Not concerned particularly about that. So where were we? Deallocate, in other words. Instances that deallocate at the end of the program, on the other hand, do not execute their deinitializers. They do not need to. All the application's memory is being reclaimed anyway. So an instance method of a class, which would be this simulation, yeah, that would be an example. An observable scope issue that can plague more complicated apps. The second reason is related to, wait, that kind of got garbled up. Okay, variables, yeah, we got the scope part. If the variable contained a reference, the end of the enclosing scope is where it decrements the reference count, okay? Okay, yeah, that makes sense. And then instances that deallocate at the end of a program, on the other hand, do not execute their deinitializers. They do not need to. They deallocate at the end of a program, on the other hand, do not execute their deinitializers. They do not need to. Okay, I don't know what that means, but hopefully they explain. At the end of a program, meaning what? They do not need to. So an instance method of a class like simulation run method provides an observable scope where you can model the memory management issues that can plague more complicated apps. Oh, so you call it, are they calling that a program unto itself? The second reason is related to tooling. In this chapter, you will use Xcode's memory graph debugger to find and fix certain memory related issues. If all you wanted to do was demonstrate object allocation and destruction, a do scope in main Swift would be plenty, but the memory graph debugger is adept. Why the fuck is it doing that? Can you stop, brother? Second reason related to tooling. Memory graph debugger to find and fix certain memory related issues. I'm dying. If all you wanted to do was demonstrate the object allocation, a do scope in main Swift would be plenty. But the memory graph debugger is adept at finding memory issues in more complex applications built from relationships between types. So, for the sake of this exercise, to simulate an object graph more in line with the tool's expectations, you will run your experiments from within an instance method of a class. Okay. I can read to you. And then it just stopped. I can't. Why can't I hear the Elgato properties? Oh, it's muted. Okay. No, send it. See if it's any good.
As you might recall, are defined by pairs of braces.
Okay, just kidding. Rather listen to myself. All right, so build and run your program. Created Vault 13. All right, so Command R. All right, that's what we need. It's building, it's doing something. All right. Cyclical Assets wants to access files managed by iCloud. I'll allow it. Get up in there, brother. All right, created Vault 13. Vault 13 is being deallocated. Program ended with exit code 0. Hot dog. All right, and okay. The Vault 13 variable contains. Is it doing that because I changed to scrollable? I think it is. It's not worth it. Creating the sim. Top level. All right. The Vault 13 variable contains a class instance, a reference type. By default, all references that you create are strong references, which means they increment the reference count of the instance they refer to for the duration of the existence of the reference. Okay. Therefore, the Vault instance has a reference count of 1. Oh, in our other file. Yeah. Okay, that didn't work. You can see the Vault 13 of 1. After it's created and the reference to it is stored in the Vault 13 variable. Oh, wait. It has a reference count of 1. The instance does. Okay. After it is created and a reference to it is stored in the variable. Oh, okay. The variable. When run finishes executing, the Vault 13 variable falls out of scope and is destroyed. Okay. So my graph earlier was totally wrong. Yeah, so okay, I wasn't thinking about it the right way. Because this is like not a thing until we actually create an instance. Is that true? I'm not sure if that's true. guess it'd be any language, but so in Swift, when you write a class, does it exist in memory anywhere prior to creating any instance of it? Okay. So no. Yeah, so I should amend that little graph from earlier, but okay, that makes sense. All right, so then is being deallocated. When run finishes executing, the vault 13 variable drops out of scope and is destroyed. So you're saying I create the instance, so there's a reference count of 1. And then I run the simulation. Dot run, so I run this method, let vault 13 equal and what was vault? Vault was also itself, oh, a class, okay. Was itself a class, so let vault 13 equal an instance of vault, and then print created. Oh, and since that's the end of its scope, that's where it sends, I mean, hypothetically, or not hypothetically, sends the decrement to the reference count, bringing it back down to 0. So then it would also deallocate the memory, all in that one run. So that's why it's created, and then vault 13 is being deallocated, because the instance of the class has this D in it, and it says self is being deallocated. All right. Okay, that makes sense to me. So then what? Drop to 0. Next, create a new Swift file called asset.swift. Asset.swift. 1 and new. It's a Swift file. Next, asset. Okay, close that bad boy up and go down there. And define an asset class that also conforms to custom string convertible. Alrighty. Class asset. Let name. So we have a property called name of type string. Another property called value. That'll be of type double. Now a mutable variable or mutable property called container of type vault. A vault, optional vault. So that could be nil, could be nil, and then init. So we have our initializer per usual. So on the caller, we'll have to pass the parameter name, and we'll have to pass in a string and a parameter of value, and that will need to be a double. And then we take what we passed in the name, or we take the argument that we pass in for the name parameter, make that equal to the property name for that instance, and we do the same for whatever we passed in on the initialization value, make that equal to the instance's value that it will hold. Makes pretty good sense. All right. And oh, we were not done yet. And then that's the initializer. So then de-initializer, print that itself self-referential to the instance is being deallocated. All right. Now an extension on the class. Oh, that needs to go outside. Yeah. Command Shift Y. There we go. Extension. Asset. Custom string convertible. So we're saying now the class via the extension asset needs to conform to custom string convertible protocol. For description of type string, and this is the string representation we want to use via this logic. So if let, so conditional creation of this constant here. If the condition is true, otherwise do something else. So we're saying if let container equal container, if let container equal container. Okay, equal container. Oh, there it is, container. So basically, if it's not nil, then return this string asset. Escape character, string interpolation, name. So asset X worth this value in this container. Okay. This container. Yeah. Else, so if it is nil, then just return this instead, this string asset name worth value not stored anywhere. One, two, three. Okay. Why is that open? Okay. The asset class is very similar to the vault class so far. Asset has some useful properties, conforms to custom string convertible, and prints a message when it is deallocated. It also has a variable stored property, container, which will refer to the vault containing the asset. Container is optional because it is reasonable for an asset to exist in the world without being in a vault. It is okay. Oh, okay, I see. Okay. Create a few assets in main Swift. Okay, now how did we... Okay, control tab. All right. Nice, brother. Yeah, let me just get you out the way there, guy. Now... What else? Or no, that's good. Okay, so then beneath the print statement on what? On main Swift. Okay, we're in main Swift. Inside the method, okay? So oh, these are just properties. Okay, so yeah, property under the simulation type. I'm just not used to having the methods on top, but it doesn't matter. So a constant coin. Asset is a class, so we're saying that. Oh no, okay. So it's of type class. I mean, type asset, and it's equal to an instance of an asset, which makes real good sense. And then name value. Yeah. So we want to pass in rare coin. Tab over to that next one, and we can use these underbars in lieu of commas if you would like to have that for readability, but this is just as valid. I actually hate this, so I'm not going to do that. That to me is wildly more readable than I don't know. I mean, how many zeros are you counting, brother? To me, it's, I don't know, it just is, but it's seriously not a big deal, guys. Not a big deal. Okay, let gem asset, and we got another instance going. Big diamond. $5,000. And one more, let poem. And it's nice to see art being appreciated as an asset. Okay, a little IP action, asset, name value, and this is magnum opus. .0. What is that? Does that mean like your masterpiece, right? Something like that. Yeah, a magnum opus or masterpiece is the greatest work of a writer, artist, or composer. Oh, okay, cool. Cool, so I guess as a dev, you could technically have a magnum opus. Neat. All right, then, oh, and then we got to print, so func run print. Created some. I'm trying to sneeze. God damn it. Sorry. Ugh. Hate allergies, man. I'm just gonna uninstall my nose. Okay, or my sinuses. Jesus. Coin. Okay, print created some assets and then print this array. Oh, with each of our properties. Okay, coin, gem, poem. We need no spaces, brother. What you talking about? All right, and then there. All right, nice. So does that mean that? Does that mean? Oh no, it doesn't mean that. I was gonna say I didn't know if that would be like simulation.print to call that, but this is inside the method, so it's just gonna run whenever we call the .run. Okay. Build and run your program. Alrighty. Let me get the console up. And ready, 1, 2, 3. Command R. What do we got? We got what they got, maybe. Created some assets. Asset rare coin worth 1,000, not stored anywhere. Asset big diamond worth 5,000, not stored anywhere. Asset magnum opus worth 0, not stored anywhere. Okay. And then we get asset magnum opus worth 0, not stored anywhere, is being deallocated. So each one is being deallocated, which makes sense because they're all in the same method. And since oh, okay, I see. So since they're inside the method, they're created as part of it. This runs, but then we get to the end of the scope. And when these were created, the reference count went to 1. When the scope ends, it's back down to 0. Therefore, they would be deallocated. Okay. Build and run your program. As with Vault 13, the 3 asset instances deallocate when they're... Wait. Build and run your program. As with Vault 13, the 3... Okay, I'm not going to lie to you. I got to go to the... luckily, nobody's watching today because, boy, stomach problems, you know what I'm saying? But, Jer, still make sure you get this out in post, brother. I saw one of your edits. You left some of this shit in there. Okay, BRB. We'll be right back. At... I don't need long. I just got to take care of nature. Okay, just maybe 10 minutes. So let's say we'll be back at 12:53 CST. And ridiculously large text. All right. 12:53 CST. Be right back. always knew that my little crime would be cold. That's why I got a heater for your thighs. And I know it's not your time. But bye-bye. And a word to the wise: when the fire dies, you think it's over, but it's just big. Okay. That concludes our musical intermission. And we're back, brother. Light this shit up. All right. Light this stuff up. So, where were we? We just ran this little chunk of code here, and we understand why these were immediately created and then deallocated, because they are all in the same scope. And since this was the first instance of them and the only instance of them, they had a reference count of 1. They get to the end of their scope. When you get to the end of your scope, it decrements the reference count by 1. 1 minus 1 is 0. When it's 0, the instance is destroyed. Memory is deallocated. And that's what this string of console logs is telling us. Okay. Now what? Build and run your program as default. And since they're... Oh, it's just showing us the same output. Okay. Now you will make things interesting. It is time to fill the vault with assets and see what happens. Go back to Vault Swift and add a property. Motherfucker. Go back to Vault Swift and add a property and method for storing assets. Okay, go back to Vault Swift. Yeah. Command J gets me in the editor. I wish it would just go there instead of... I'm not sure why it gives me this highlight and then I gotta press enter, but it works. Back to Vault, add property. Okay, so under our property integer or number, I want a private set we've not seen this yet. Yeah. Well, duh, but it's a new section, but still. Okay, so private parentheses set var assets equal an array of asset type and an empty tuple, because we are initializing this as an empty array initially, but it'll hold the type asset. Okay. And what else are we adding? Under the D initializer, we're adding a method, another method, func store. Drooling on myself. And underbar for an external anonymous parameter name, meaning we won't have to write the parameter name when we pass in the argument. Internal parameter name will be asset, and it should be of type asset. Open up the body, bust it wide open, then asset dot container will be equal to self. What does that mean? The asset dot container. Oh, on our other file. So when we initialize, no, not initialize. When we call this method, we'll pass in an asset. And if asset.container has because this is an optional type, right, in the container itself, the property. So maybe there, it may not be. If it is there, we're saying take the instance of that asset, take that container value, and make it equal to itself, the object, the instance. Pretty trippy, brother. Okay, so equals self, and then assets Okay, that's in, yeah, that's within our scope here. So not the other asset, but assets plural. Okay, so that's assets dot append asset. Okay, so when this method runs, we are establishing the container value in our instance of asset asset.container. Is that right? It would be, yeah, that's right, that's right. And then assets.append asset. So we'll just add to this array that we created up here initially. So those are the two things we're doing. So establishing the container value for the asset type itself, and then we append the asset to the empty array. Okay. Should I run it? Let's run it. Command R. What happens? Let me make this bigger. So there's our method, and then this dilly. All right, let's see what they say. You add assets, an array of asset. Okay, now it's too big. Okay, so we add assets, an array of asset. A lot of ass being thrown around here, but it's not that kind of stream, brother. So red here. I want it to be temporary. There we go. Okay. Yeah, assets. You add assets, an array of asset instances that the vault contains, and store a method. So this one, the store, a method to put an asset in a vault. Put an asset, because that's what we're passing in here, into a vault. Yeah. Okay. The method store adds the asset passed to it to the assets array and sets the assets container property to refer back to the vault that the method is called on. And sets the assets container property to refer back to the vault that the method is called on. Oh, okay, I see. Okay, so okay, that does make sense. So whenever we just hadn't added them yet, but all right. So I guess I could just do it and then explain it. Okay, so you add assets in main Swift. Put a couple of the assets in your vault. All right, let's do that. Simulation run. Where's so inside the method itself. Let poem and then vault, or you want it above it. Got to be just right. Vault 13 dot store. So that's our method. And because of that little underbar, we don't have to name the parameter. We can just throw it in there. And so, but wait, I want to see something. So the store, yeah. So single parameter. Asset, and we want to pass in the value coin, which coin up here is an instance of asset, and it has name and value associated with it, but this takes the type asset, so that's good to go, coin. And then vault, vault 13, store another asset, our gem. Build and run again. Okay. And we got created Vault 13, created some assets, a rare coin in Vault 13, big diamond in Vault 13, magnum opus not stored anywhere, and then asset magnum opus worth 0 not stored anywhere is being deallocated. Oh, I see. So now only magnum opus not being stored anywhere, i.e. has no container value. Only that one was deallocated this time. Now, since we called, wait, so we're creating asset instances. No, we're creating vault. No, we're not. Yeah, these are asset instances. Vault 13 is just this, that daily right there. But that is an instance of a vault. This is why I hate classes. Okay, so it really is. But this is really the, okay, so this is the instance. I mean, these are two, but they're being consumed because we're passing those into the method. And so now, since they have, because wait, now what was the store method doing? Store asset container. To itself on the caller. So, okay, but the caller is in asset. Whoops, I mean in main, here we go. So the caller itself is this. And so self would be the instance, Vault 13. And that becomes the container. Container is a property here in asset. Okay, I get that flow. I don't understand why it didn't deallocate still. So let's find out. Okay, so I might not have any voice left by tomorrow, sorry. Okay, so then build and run again. The output may be surprising. Let me just make sure we got the same thing. Created some assets, asset rare coin worth 1,000 in Vault 13. Worth 1,000 in Vault 13. So, okay, we got the same thing. And the next one in Vault 13. Yep. And then magnum opus, not stored anywhere. Deallocate. Okay, so we got the same thing. All right, the only instance being deallocated now is poem. Its reference count dropped to 0 as expected at the end of the scope. Coin and gem, which are in the vault, oh wait, that doesn't make sense. Coin and gem, which are in the vault, and the vault itself are no longer being deallocated. Why not? Yeah, why not? Take a look at figure 24.1, which shows the reference relationship between any of the variables before any of the variables are destroyed. Okay, let's make that a little bigger there, brother. Okay, so why not? This shows the reference relationships before any of the variables are destroyed. Var vault 13, reference count of 3. Because, where's 3? 1, 2. Asset, rare coin. Reference count 2, asset, big diamond. Reference count 1. Wait, literally from all directions. So the var vault 13 is a reference, 1. And then the asset rare coin uses vault as its container, or an instance of vault as its container. So that's two references. And then Big Diamond does the same. And so that's how we get 3. Okay. I didn't realize it was like literally every touch point, but that makes sense. If you got to use some of it, you got to use all of it, or you need the whole object there. Okay, so that, okay, makes sense. Then reference count. So the asset itself, actually, maybe I do want to shrink this because now that I get what's cracking, let's look. Just for this part, I can make that smaller. Okay. So Vault 13. Where are you? Main. Yeah, here we go. Store. And store, the method store. How do I do go to definition? Is GD? GD? Oh, brother. Oh my gosh. That is awesome. Okay. All right, I'm not gonna say anything. You have any idea how much time that would have saved me? Okay, all right, func store asset. And so this is a reference to asset from within Vault. So when we call store, then by definition we are making some reference, a reference to asset. Okay. Which is why each vault, okay, okay, all right, I got it. Which is why, so we have 2 vaults, right? We have 2 instances of Vault 13, and we're calling the store method twice, so store method over yonder. And I need you to get just a little bit bigger there, buddy. There we go. Yeah, so these 2, this is killing me. All right. Yeah, these 2 instances call that store method. And they reference asset, and that's represented here. So the 2 vaults, you can see the 2 arrows to the assets, 1 and 2. Therefore, each of these assets have a reference count of 2, because the coin on the other side, is that in main? Where do we? Yeah, so these on the other side are also referencing the instance, and so that's another reference. So calling the method and then just the initialization period. So one for each, and then on the other side the variable 2. So 2 for each one there. And then since Magnum Opus did not get a container assigned, there's no reference to Vault 13, and so the only thing that's referencing it is the instance itself. And since it's within the scope of the method run, if nothing else is referencing it, it's just destroyed. Nice. That makes good sense. All right, so then each instance of vault and asset is depicted within a rectangle labeled with its current reference count. Remember, Vault 13 is not the instance itself. It's a reference. but is instead a reference to an instance of the Vault class. Okay, the reference count in the rectangle is exactly the number of arrows pointing to the instance. Yeah. The number of references to the instance. As your run function returns, those references go away, leaving what you see in figure 24.2, cyclical assets. After this completes its run, this is the state of things. Vault 13, 2 references still. Yeah, 2 references still. So Vault 13 represented here. So this one coin, this one gem. So coin, reference count 1. Wait, why is gem? Oh, gem is big diamond. They're just putting the name in there. Okay. Yeah, so 1 and 1, and then to Vault 13 there is 2. Hot dog. And so yeah, so I suppose in reality there's all this going on in terms of references, and those are being stored with the variables, and then somewhere in the background, provided that there is some reference to it, then the actual class, the actual asset class, or sorry, the vault. Where did we go? Yeah, so the actual instance of this class, these properties, they exist somewhere in memory, like somewhere in the background, and all these references just use those properties. So there's only one set of these in memory for Vault 13, for that instance. And all these things just reference to that same spot in memory. Okay. Yeah, okay, that makes sense. You have created 2 strong reference cycles, which is the term for when 2 instances have strong references to each other. Vault 13, Vault 13 has a reference to the coin via its assets property. Oh, right, this is the simulation. So in asset, there is the where did it go? Via its assets property. Oh, here. Okay, that was weird. Yeah, so here, okay, yeah, So this is the vault class, and then here is the assets property. It just looks weird because we still haven't gotten to what is that doing right here. Okay, so here's the assets property on vault. Yeah, so Vault 13 has a reference to the coin via its assets property, and the coin has a reference to Vault 13 via its container property. And the coin, so the coin has a reference to Vault 13 via its container property, meaning it is of type asset. So asset has this container property, and that gets populated when we run the store method here. Okay. You can see the weaving web here. Blah, blah, blah. Yikes. So this is why I say just get a really bitchin' server, brother. Pile it up with RAM and just copy everything. No, not really. So the same for Vault 13 and Gem. The memory for these instances is no longer reachable. In the Gem, yeah. The memory for these instances is no longer reachable. All the variables containing references to them are gone. But the memory will never be reclaimed because each instance still has a reference count greater than 0. What? You've created two strong reference cycles, which is the term for when two instances have strong references to each other. Oh, okay. To each other. Vault 13 has a reference to coin via its assets property, yeah, and the coin has a reference to vault via the container property. I got you. Okay, so they depend on each other in some way to establish some property within its own type. In this case, vault, assets, and asset container. Yeah. Okay. So I get that part to each other. Same for Vault 13 to the Gem. Oh no, we read that part. The memory for these instances is no longer reachable. So we're saying that no longer reachable in terms of after the store method. Come on, brother. Or not store method. After this runs here. The method run. Simulation.run. But this is the weird part. Okay, so the memory for these instances is no longer reachable. All the variables containing references to them are gone because they're all within scope. They're all scoped here. But the memory will never be reclaimed because each instance still has a reference count greater than 0. Oh, so this is like shitbag code that you don't want to write. I see. Okay, so that makes sense. So I'm surprised it's even... But that's allowed to run. Yeah, that runs. I'm surprised. Okay. Strong reference cycles are one kind of memory leak. Your application allocated the memory necessary to store Vault 13 and its two assets, but it did not return that memory to the system, even after your program no longer needed it. Dang. Without the console, how could you have known about these memory leaks? Xcode can show you. Xcode can show them to you directly. Really? Xcode has several built-in tools that you can use to try to identify leaked objects and the references to them. You will take a look at one of these tools. Hold on, this is bothering me. I gotta. OCD, just hard trigger. Okay, so strong reference. Even after your program, Xcode can show us. All right, Xcode has several built-in tools that you can use to try to identify leaked objects and the references to them. You will take a look at one of these tools, the Memory Graph Debugger, in a moment. But first, to allow it to examine your program, you need your application to keep running when it reaches the end of main Swift. But first, to allow it to examine your program, you need your application to keep running when it reaches the end of main Swift. Oh, right, because so they actually, yeah, I just need to ask a quick question. We're gonna come right back to it. I swear it. I'm more so telling myself this, but I do want to understand because it was kind of just thrown out there. And I didn't dig into it at the time, but when we first covered it was when we first did it was the first project, Monster Town. So let me just go find. That had to have been when we started working with classes, but it said there was some behavior where it runs top down in a procedural fashion when you're talking about a command line project. And so I want to understand to what extent that affects things here now that we're back on that topic. So command line, uniquely, do not worry, it's somewhere here. Here, inspect your area at the bottom of the Xcode, the top of the window. Okay, good, I highlighted it. Good on me, brother. In a command line tool, main.swift represents the entry point of your program. Like a playground, main.swift executes top to bottom. After the last line of code in this file, after the last line of code in this file executes, the program is complete and exits. To let main.swift define the procedural story of your program, you define custom types and functions in other files and then use them in main.swift. Yeah, so this is what I would like to, like, is that always the case, or is that just a command line tool? Or is that a setting? Like, what does that mean? Because then, I mean, Go is a little different in that you can write code effectively anywhere. There are some rules, like with the packages and stuff like that, but in terms of like where it ran, which I always kind of liked, so it wasn't a bad thing necessarily, but you know, you have to have like in Go, you have to have the main function isn't like implicit, so you have to actually write it. So at the top of your file, you do like package main, you import stuff from the libraries wherever, or other, you know, source code, and then you have a inside package main, you gotta have func main arguments, and then whatever is up in there, and then only inside the body of the main function is it procedural. So, you know, but everything else, like everywhere external in that same file in the package main or elsewhere, you know, you can write, you know, whatever the sequence does. It doesn't matter. The top down aspect doesn't matter, but only within the main function does it. And so I'm sure that's kind of clouding up what I'm thinking about here, but either way, we're finna find out, brother. So here, come here. Okay, this. Here, given the below excerpt from a SwiftLang book, can you clarify as to whether the top-down procedural execution described applies to all Swift programs, or is it isolated to command line tools, and if so, how does one dictate the type of tool? So it is isolated to command line tools. Okay, which is what the book said, to be fair, but it just struck me as odd, is all. Because where do you set that? I mean, whenever we created the, you know, it's just different, but whenever we created the project, we do choose the kind of tool, but it just seems, it sounds weird to say in Swift because it's not been the case in any other aspect of the language, but I don't know, it just seems restrictive. Like you make that choice up front for your whole main Swift file. It's just surprising, I suppose. For Swift command line tools, main Swift acts as the entry point of the program. The program starts execution from the top of main.swift and proceeds line by line until it reaches the end. In this setup, main.swift typically includes the high-level procedural logic, while additional types and functions are defined in other files and used within main.swift. Playgrounds behave in this manner, which I think that's just kind of expected. At least that was always intuitive to me, so that makes sense. And then, yeah, you know what kind of pisses me, just a quick aside, Jupyter Notebooks. And the fact that they let you execute out of order with no protection against like dependency aspects or references within the, just the biggest downfall of a spectacular tool. I love the concept, but yeah, fucking Python. All right, but iOS, macOS, tvOS, watchOS. What about this? Event handling. Oh, okay, yeah, whatever. But okay, so this is just saying that it is dependent on the type of tool, and so it is isolated to the command line tool. And so I guess you'd have to start a new project otherwise, if you wanted that to change to command line tools and playgrounds. Other types of Swift programs such as iOS that follow a different execution model driven by the application's lifecycle and event handling mechanisms provided by the framework. Yeah, okay. So I guess my only other question is, does that mean or no, what do I want to ask? Just out of curiosity, is there a way to write apps in the same fashion where a single file represents the procedural sequence of events you'd like to take place? I guess that makes sense. It would have to be event driven, because how could you, or it wouldn't be a very useful app, I suppose, if you had to use the same sequence every time. Or it'd have to be very specific, like that's almost like a scripting app, you know? And it just executes and runs the script in whatever order you write it. But what are they showing us here? Simulating procedural execution in an iOS app. While you cannot entirely avoid the event-driven nature of iOS apps, and we don't want to, just to be clear, you can design your app to have a more linear flow of control by using the app delegate or scene delegate and controlling the sequence of method calls. Okay, so we're going to read a whole book on that, so I won't belabor the point. I was just curious. Okay, so that is, in fact, isolated to command line tools, so that's good to know. Now we get back to biz after a water break. All right. So they were saying that we want our program, since it's a command line tool and it's exiting when it gets to the end here. So here, after it runs simulation.run, it would exit the program, but we don't want that to happen. So they're saying we should add dispatch main. Oh shit. All right. The dispatch main function starts an infinite loop. It is intended to be used by event-driven apps to check for user input or other events. Oh, man. But it is a handy trick. Oh, let me highlight that, brother. Yeah. And then I also want to remember that right there. So we'll keep that one too. All right, the dispatch. Oh, we read that. Build and run your program again and observe the output. All right, let me blow this up there, guy. Make that bigger. Command R. What do we get? Created Vault 13. Created some assets. Our rare coin, our big diamond. Asset magnum opus worth 0, not stored anywhere, is being deallocated. It doesn't look different from last time. Notice that the message program ended with exit code 0 is missing. You're right. You're right. That was there last time. I'm wrong. Exit code 0 is missing because the program is still running. There is also a message confirming this in the Xcode main toolbar. Where's that at? Running cyclical assets. Oh, up here. Oh, I gotta get my... Is it A? Did I set these up? A. I gotta get on the mouse anyway, though. It doesn't make sense. Man, this thing is so good on Windows. It's not awesome on Mac, but it's not terrible. Okay. Anyway, up here, if you can see that. So running cyclical asset. I was wondering what the hell I was doing up there. Sometimes it looks like it's running anyway before it does a little buffering dilly, whatever that means. But no matter. In the debug area, just above your output console. So here, this little bar. Find and click the button for the memory graph debugger. Okay. Found it. Find it and click it. All right, brother. Clicked it. Oh, shit. Sorry. I love that. That's pretty cool. Okay, your source code will disappear and be replaced. This is really cool. Let me just nerd out for a sec. I can punch in, brother. I can save it. Are you? All right. And this, folks, is the Apple roller coaster. They just pepper you with really annoying, frustrating shit, and then really, shit like this too. It's like that. It's like that one girl you should break up with, but no, I'm just kidding, baby, if you're listening. There are no other women in my life. Let me not get canceled up here. Your source code will disappear and be replaced after a few seconds by a diagram of objects in your application, which should look something like figure 24.5, which we don't see yet on the page. If the diagram does not load, you may need to relaunch. We will explain. Okay, well, ours did launch, so we're not worried about what they got to say right there. So what are we saying? Okay, here's the memory graph. Looks much like ours, indeed. Look at all this detail. Look, that's awesome. Okay, look at the debug navigator on the left side of the Xcode window. The memory graph debugger has listed all of the allocations from all the frameworks and modules in your application. You only care about those from your own code, which are conveniently at the top of the list, 24.6. So where is that? Okay. How do we, oh, I see, because yeah, these are under the umbrella of Foundation. Foundation is the framework that we import, i.e. not our code, just Swift standard library. So if we minimize that, then we can see, damn, and they even got it broken down by oh, that's the project file, so that makes sense, cyclical assets, and then by class or by type. So there's asset, 2 references, simulation, vault. That is so sick, man. I'm going to take a little bit to get over this, but that is awesome. Hot dog. Okay. Each item in this list is an instance of the type that it is listed under. Yeah. If the editor area, I don't know if y'all can't see. It's just so you kind of know where to put your eyes. So this is at the project level here, and well, even that's kind of small. Shoot, bigger, brother. So project level here, so it's saying a total of 4 references, and then this says asset. If you can't read that, that's a 2, and then these are the 2 references. So these are, whenever you see 0x, that is a, God, I already forgot. It's a hexadecimal. I'm gonna have to check real quick. But the 0x tells you that it's a certain kind of number format. What does a prefix of 0x indicate? Hexadecimal, yeah, it is hexadecimal. So base 16 notation, yeah. So that's just some address, right? In memory when we see that, but that's what those are. So these are places in memory. Okay, and then Select the first asset. If the editor area does not look like graph 24/5, select the first asset in the list to see the graph. Okay, well, we see it. Notice the purple triangles. Mine are yellow, brother. Is that what you mean? Yeah, mine are yellow. They are like the symbol Xcode uses to indicate a warning in your code. Yeah, purple. Why? Yellow definitely makes sense. A lot more sense. Like everywhere else in the world, but a different color. These symbols indicate instances that have leaked. Oh, maybe I'm just not. Are they elsewhere? No. Yeah, guess it's just my color theme. Shoot, I don't know. Sure enough, your program has leaked 2 instances of asset and 1 of vault. So here's 2 leaking for asset and 1 for vault. Okay, as indicated by the tiny little orange hazard thingamabob. Asset tray. In your graph, you should see 4 allocations. Yeah. Zoom in a little bit. You should see 4 allocations, 2 called asset. 1, 2. Or yeah, that'll be. Turn that off, guy. Okay, so here's the first one and the second one. One called vault. Yeah. And one called something like contiguous AR. Yep. So that's this guy down here. And the last one begins with an underscore. Yeah. To let you know that it is one of Apple's private types. It represents the assets array. Yeah, so it's hard to see, but that little right there is a Swift dot and then underbar ahead of the name. Okay, so then what? Hey, watch it, buddy. And there. If you follow the arrows in this diagram, you will see that they represent the same thing as figure 24.2, a pair of reference cycles, one between each asset and the vault. Yeah. Yeah, exactly. So I won't poke around with it just because it is the same as the diagram we looked at earlier. A pair of reference cycles, one between each asset and the vault, with the assets array making up the third node in each cycle. In short, the vault owns an array which contains references to the assets, which have references back to the vault. Whew, that was a lot to parse. The Xcode Memory Graph Debugger is a great tool to use when you want to look for memory leaks. It will show you the shape of the leak, shape meaning the other objects and references involved, yeah, which can help you figure out how to fix them. You will fix this leak shortly. All right. Yeah, that's really awesome. That is so cool. Yeah, you know what's tough about, I mean, not really tough. You just got to make a choice. You know, it's life, right? But this is partially, I didn't know this existed. I just knew that generally speaking, you know, if you want to write in this domain, there's been progress elsewhere, but the fact of the matter is Xcode's still going to be the best choice for Swift, especially for Swift. I would argue even less so with, you know, prior to that with Objective-C, but now for sure, since Swift is, you know, 100% theirs, made it in-house, it was designed around, you know, the Apply way, the Apple way. So, but that's fine. You know, I really think for what it's worth, after bouncing between many editors. I would argue if you have a decent, even these days, like even an $800 laptop, like I don't want to put specific specs on it because I can't, but these days, like even a mid-level laptop, you're not really gonna run into a ton of issues working on personal projects in terms of whether you choose VS Code, Sublime, Xcode. But yeah, I mean, some are just snappier than the one over the other, but I found similar. If you put in the time to learn your keyboard shortcuts, you can achieve similar things with all of them. It's silly to waste time on it. If this tool feels intimidating at first, that is normal. It can sometimes show you useful data quickly, but if you look at it and do not find the graph, helpful, you can always use other strategies like printing, like adding print statements to your D init methods. I don't want to do that. Yeah, no, this to me, it makes way more sense because, I mean, not everything benefits from a visual, but to me, this is something that absolutely does. And what is that? Who's been eating sugar pops over my fucking monitor, or freaking monitor? Okay. There we are. Okay. Click the continue button in the debug toolbar to exit the memory graph debugger and return to your code. Click that. Oh, this guy right here. Yeah, that's really cool. It tells you how much memory, 4 megs for this program to sit there and run. Okay. Let's collapse this then. Bring this back to a bit of normalcy. All right. Breaking strong reference cycles with weak. The solution to a strong reference cycle is to break the cycle. You can manually break these cycles by looping over each asset and setting its container to nil while you have access to those variables before the function ends. So somewhere after print, we could do it, or before. But that would be tedious and error prone. Yeah. That's what you got to do with C, by the way. So, I mean, for whatever that's worth, but that's how it goes, brother. You write it, you handle it. Instead, Swift provides a keyword to get the same effect automatically. Modify asset to make the container property a weak reference instead of a strong reference. Modify asset, okay. So asset file, commit or control tab to get over there. And instead of the value, oh, up here. So for container, how do I do beginning of the line in Vim? It's shift $? No. Oh, 0. That's right. Okay. All right. Weak var. Okay. We still haven't covered what that private set meant, but we'll get there. Weak var. Okay. On the vault now. A weak reference is not included in the reference count of the instance it refers to. In this case, making container a weak reference. Hold on, I gotta turn the air up. It's getting hot. Sorry for the light. The light noise. I know, it's annoying. But I'm also melting. This damn place, it's the only thing I don't like about it. The damn turbine for a air conditioner is so loud, brother. All right, so instead of okay, weak var. Okay, so we got there. A weak reference is not included in the reference count of the instance it refers to. In this case, making container a weak reference means that when you assign Vault 13 as the container of the coin and the gem, Vault 13's reference count does not increase. Vault 13. Okay, yeah, okay. The only strong reference to Vault, I'm trying to take my socks off and read at the same time with my feet. It's not going well. The only strong reference to Vault 13 is the Vault 13 variable in main Swift. All right, so then that means we can take that to mean that unless stated otherwise, when we're writing classes, if we need to, that hey babe, that those are strong references by default. Strong references by default. Otherwise, we put this weak keyword in front of them. A weak reference is not included. Oh, I read that already. Making container weak reference means that when you assign Vault 13 as the container of the coin and the gem, Vault 13's reference count does not increase. The strong reference to Vault 13 is the Vault 13 variable in main.swift. Now, hey, give me a kiss. Where are we at? Increase only stronger. Okay, I see. All right. So we broke the container, or not broke, but we have explicitly stated we don't want that to add to the reference count. So now it's only coming from this direction. Okay. All right, now what? Now when Vault 13 variable is destroyed at the end of run, so at the end of this method, the reference count on Vault 13 drops to 0, so it is deallocated. When Vault 13 is deallocated, it no longer holds a strong reference to its assets, so the reference drops. Well, so the reference count drops to 0 as well. When Vault 13 is deallocated, it no longer holds a strong reference to its assets. I see. Okay. Run your program again. Xcode will ask whether you want to stop SwiftUI because it's already running. Click stop to terminate the old instance and launch a new one. Oh, okay, replace, yeah. Okay, and now we see, so this Vault 13 is being deallocated, not stored anywhere, being deallocated. Big Diamond, not stored anywhere, being deallocated. Okay, whereas before those remained as memory leaks. Okay, I see. Confirm that all the objects are deallocated. Yep, so asset is deallocated there, and then on the last two lines are rare coin and big diamond are deallocated. Okay. Yep, that's what I got. All right. You can check the memory graph debugger again to verify that there are no vaults or assets remaining in memory. Okay, let's do it. Very nice, very nice, very nice. So now over here under our project simulation, and we have no warnings. Can you what does that do? Oh, it just takes you to your code. Okay. Let's see. Only the simulation that you defined in main Swift remains. Yeah. What happens to a weak reference if the instance it refers to is deallocated? What happens to a weak reference if the instance it refers to is deallocated? The weak reference is set to nil as soon as the instance begins to deallocate. The weak reference is set to nil. So go ahead and close that. Oh, okay, so it would set container to nil if what? What happens to a weak reference if the instance it refers to is deallocated? The weak reference is set to nil as soon as the instance begins to deallocate. Okay. You can see this by looking closely at your console output, not stored anywhere. Yeah, because we had in this run method, all right, we have this method store, which, wait, define it. Have a weak reference. Yeah, and so inside the store method, we assign the container asset.container, but since container, the container property in asset, if we go back to asset, is a weak reference, they're saying that it will automatically set that to nil if the instance, in this case these two, if it's deallocated. Okay, good. I mean, yeah, that makes sense, because it would be deallocated here, has a weak reference, so then it goes and sets the container to nil to get rid of that memory leak. Okay. Okay. What happens to a weak reference if the, oh no, we read that already. Your log statements show that the vault begins deallocating, logging its deinitializer. So deallocating, logging its deinitializer first. It does, so vault 13 is being deallocated ahead of these two assets being deallocated. So that happens first. This is true. But so what? What are you saying about it? It then destroys its properties, including the assets array, which is a value type, so the whole array is destroyed. When the array deallocates, so do the references it contains. Ooh, trying not to yawn. Didn't work. When the array deallocates, so do the references it contains. And what does that mean? So the array, where is the array? It's in vault. Vault contains an array of assets which contain these properties. Okay, gotcha. Gotcha. So then, when the array deallocates, so do the references it contains, which causes the asset reference counts to fall to 0, allowing them to begin deallocating. As each asset begins deallocating, its own deinit method executes, showing that since the vault has already begun to deallocate, the weak container references to it have already been set to nil. Oh, I see. Yeah. So it's not necessarily explicitly shown, but they're saying that before these could ever be deallocated, the reference count, because of the behavior, would be 0, meaning at some point before this weak reference count behavior we're describing already took place. Because the only way the deallocation of these reference types is automatic, and it only happens when the reference count is 0. So that's what we're yapping about right there, brother. And then The log statements in the yeah. Count to 0. Begin deallocating. Yeah. As each asset begins deallocating, its own deinit executes, showing that since the vault has already begun to deallocate, the weak container references to it have already been set to nil. There are 2 requirements for weak references. Weak references must always be declared as var, not let. Okay, so just like so. Weak references must always be declared as optional. Weak references must, oh, okay, so on the type declaration, regardless of what it is, it needs to be a double. Okay. I already forgot what it was, so Control Z, nice, brother. Oh, that's cool. It saves it per line when you Control Z, not, wow. Oh, weak. Okay. All right, so those are the 2 rules. It has to be a var if you're going to use the weak keyword to use a weak reference, and the type has to be an optional, which is indicated by the trailing question mark after the type name itself. Okay. So these are both of these requirements are the result of weak references being changed to nil if the instance they refer to is deallocated. Oh, I see. So it can't be let because you got to be able to change it. So var, and then optional because we need to be able to handle nil. All right. The only types that can become nil are optionals, so weak references must be optional. And instances declared with let cannot change, so weak references must be declared with var. In most cases, strong reference cycles like the one you just resolved are easy to avoid. Vault is a class that stores assets, so it makes sense that it would keep strong references to the assets. Asset is a class that is contained by a vault. If it wants a reference to its container, that reference should be weak. Yeah, so I mean, to me, anything upstream should be weak if that's the case. I mean, if you really wanted to like double down on classes, like if you had a parent class and then like others beneath it to represent your strong references, like anything, maybe that's a few too many boxes, but yeah. So this, like anything that would come from here and reference this object above it or some property in it should be weak, and then the same would apply to anything from the second level up to the parent level. Yeah. Yeah, I mean, this is a concept that applies in a lot of different domains, matter of fact. So yeah, that makes sense to me. Okay, so then if when faced with two types that want references to each other, try to determine which one is the parent object in the relationship. That is the object that should own the other object with a strong reference. Yeah. Not all strong reference cycles are caused by objects with explicit properties referring to one another. Not all strong reference cycles are caused by objects with it. Okay. Recall from chapter 13 that closures can capture variables from their surrounding scope. By default, closures also keep strong references to any class instances that they capture. By default, closures also keep strong references to any class instances they capture. Okay. All right. Reference cycles with closures. So this would be more like what we're going to write after we finish these books. So this would be cool. Sometimes assets appreciate or depreciate in value. To demonstrate some closure-related memory management behavior, you will teach asset instances to react to changes in their value using a provided closure. In your asset type, allow value to be mutable and react to value changes by executing a stored closure of type asset return type void. All right, brother, if you say so. So okay, we're already there, asset, and you want me to get rid of this constant, let value double, and oops, and instead we'll have this computed property var value of type double did set change handler value minus old value. Change handler. Okay. And then weak var, below that we want a type alias. Value change handler is equal to type alias value change is equal to this closure. So it will take, this closure will take a double as its parameter, or as the singular argument, and it will return nothing, the void. Okay. Oh, so that's just, yeah, the type signature. So we have a type alias of value change handler. Okay. And it's equal to that closure. So pass it a double, returns nothing. Then var change handler, and it's of type value change handler, so that closure, and we pass it the function's body. I think it finally just set in for me why it's doing that. So when you define the closure as the value, you just use the signature and then when you give it a value, like the actual assignment operator, you just give it the logic that would be in the function body. Although I have no idea what this does. Underbar in, okay. Okay, asset now defines a type alias value change handler, which is a closure that takes a double, the amount by which the value has changed, and returns nothing. Yep. Asset also has a new property. It does. Change handler, which stores a value change handler closure. The default value of this property is an empty closure that discards its argument by using an underscore for the local parameter name. Discards its argument. Okay. Oh, so that's what that means in the context of a closure. So underbar and then the in keyword. Huh. The default value of this property is an empty closure that discards its argument by using an underscore for the local parameter name. Okay. Any other object, such as a vault that contains an asset, can give the asset a new change handler closure. The asset will execute this closure every time its value changes using a didSet property observer. Any other object, such as a vault that contains an asset, can give the asset a new change handler closure The asset will execute this closure every time its value changes using a did set property observer. The asset will execute this every time its value changes. Okay. I missed something here. The default value of this property is an empty closure. Yeah, so here. Or, well, I guess here, really. Yeah. So that discards the argument. Actually, you already know what's coming. I need one of the Oracle's good old hardcore breakdowns because I'm not really grasping that part. Okay, so please break down what each portion of this code is doing. Specifically expound on the type alias and break it down, brother. Let's break down the code. Alright, so we define the class. We know that. Let name is a constant property, type string, var value double. Declares a variable property value of type double. Yep. It can be changed and it has a property observer did set. It did set change handler. Okay. This probably where did set. This observer gets called every time value is set to a new value. Okay. Every time. Inside did set, it calls change handler with the difference between the new value and the old value. It calls change handler, and change handler is equal to that empty closure, I guess, but yeah, we'll see what it says because that's the part I don't get. So weak var container vault declares an optional, okay, we covered that. Type alias and closure. Yeah, here we go. Type alias is used to define a new name for an existing type. Here, value change handler is defined as a closure type that takes a double. Okay, so it's still, okay, that helps. It's still referencing the same type, just a different name. Oh, wait a minute. So then if we, so if this is an alias for asset, I guess that's just how you can tell it. Okay, let's just go read because yeah, not following that one. Okay, type alias is used to define a new name for an existing type. Here, value change handler is defined as a closure type that takes a double as input and returns void. Okay, so that's that closure signature. Change handler is a variable that stores a closure matching the value change handler type. is a variable that stores a closure matching the value change handler type. So we would only be able to, okay, we would only be able to change the value by passing it a closure that takes a double, returns nothing. Okay. Bracket underbar in initializes change handler with a default closure that does nothing. Okay, so that's all that is. So discard the local, and then the in keyword is just the separator. Oh, that's right. The in keyword in a closure is just the effectively the separator between the arguments, which is represented here by the underbar because we're just throwing them out. So it's a separator between the arguments and the function body in terms of writing a closure. So since there's nothing after the in keyword, it doesn't do anything. Okay, and it returns nothing. So the underbar in syntax is used here to indicate that the closure accepts a parameter of type double, but the parameter is ignored. The underscore is a placeholder indicating that the parameter is not used. Okay. This empty closure prevents errors if change handler is called before it is assigned a meaningful closure. I see. If change handler is, okay. Initializer and deinitializer. That part, we'll leave that alone. So I need to understand this better. So here is, are you saying the value change handler wait, is that's not what yeah, I don't know where that escape character came from, but that's okay. Are you saying the value change handler type name could be used in place of, I already forgot what is it? A class? Assets? Asset. Okay. Name. Okay, then I definitely misunderstood. So no, that is not the case. These are different pairs that represent different types. They serve different purposes and represent different types. But that's not, why'd y'all call it an alias then, brother? That's not what an alias is. It should represent the same type if it's an alias, but just a different label, different name. But okay, so no, that's not the case. Asset is a class type representing the asset objects. Yeah, value change handler is a type alias for a closure type. Oh, okay, yeah, I way misunderstood that. Okay, so that only applies for a closure type. The type alias keyword is used to define a new name for an existing type, making the code more readable and easier to maintain. Here's what it means in your code. This defines value change handler as a shorthand for the closure type, double void. I see. So it's a nested type of asset. It doesn't change the type itself, but provides a more readable name for it. I see. Okay, so that way you don't have to write that closure everywhere. You would use value change handler in places you want to specify this closure type. Okay. I see. Yeah. Okay. Instead of writing the full type double void, you use the alias value change handler. Okay, perfect. That's, matter of fact, I'm gonna save that whole thing. So comparison with asset. Asset is we get that now that we know it's different. And so, no, that makes sense. Yeah, that does make sense. Okay. You cannot, yeah. Oh, oops. Hopefully it tells me the same thing. Okay, that's fine. I really just want this part here. And let's throw this on the board here. Nothing happened. Okay, there we go. Let's see. With closures. Copy purpose. Not my favorite formatting, but that's all good, brother. All right, Xcode. Let's go back. All right, then. So we get that. So it's saying a type alias for this closure. We can just write value change handler, and then we have this change handler variable of type value change handler, and we initialize it or by default, I guess, it's equal to that empty closure that does nothing, just in case. Okay. Asset now defines a type alias value change handler. Yep. Which is a closure that takes a double. Oh, wait, I did want to ask it just one more thing real quick. So, can we consider the type alias value change handler a nested type of, okay, great. Okay, so it's a nested type. Really into labels, you know, categories. Asset now defines a type alias value change handler, which is a closure that takes a double and returns nothing. Asset also has a new property, change handler, which stores, okay, the empty closure. Yeah. Any other object such as a vault that contains an asset can give the asset a new change handler closure. The asset will execute this closure every time its value changes using a did set property observer. Any other object such as vault that contains an asset can give the asset a new change handler closure The asset will execute this closure every time its value changes. I see. So if we just pass change handler or set it to a double, oh, we can do whatever with it. This just happens. It just has to return, not return anything, but we can still, maybe, I don't know. Let's see. Let's find out. Oh no, I do. Okay, but this would differ. This can always be different. That's right. It just has to be a double here in the first slot where the arguments are, and return void. Otherwise, we can do whatever, and it'll set that to the new value with the did set. Yeah. So it'll take whatever we give it minus the old one. Okay. This strategy allows other objects to react to changes in an asset's value by telling the asset what to do in response to changes in value. I see. So it's a var. We know it can change, and if it does change and we want to react to such things, we would use did set, and we can use that logic. And then, oh, holy hell, I just realized what's cracking. Okay, and then change handler is the value, or is the property, and it's of type double. Therefore, value, whatever's already there, is here, which is the argument, minus old value. So it sets it there. So the value that gets set for the alias here, or I mean the type that's required for the closure is double. So that's okay. I got there eventually. All right, so then by telling the asset what to do in response to changes in a value. But the strategy must be implemented with care, as you will see. Update vault.swift to report its net worth every time an asset's value changes. Okay. Class vault. What do we change in var? Private set. And var total value. So a new mutable variable, or sorry, property on type vault, and it will be of type double with a stored property of 0. And warning. We saw this once before, but then they never said what the syntax was, but I think we kind of get what it might mean. Implement total value as a computed property. All right. To report your vault's total value, you need a total value property to report. Total value property. It should be a computed property, calculated by summing the values of the assets. But that is a distraction. You are busy right now and focus on change handler. So for now, you just tell the compiler to warn you about this unfinished business. Oh, so that's for developer use. Warning. Thought something was crawling on me. That's cool. Okay. Yeah. Okay. Yeah. So to report total, the hashtag warning expression is special. As are you, brother. It causes a compiler warning with the specified message. There is also an error expression to force a compiler error. These expressions are very handy when you are deep in code and need to leave yourself a reminder to come back and fix or finish something. Yeah, that is very handy. I like that a lot because it's not tied to, like, I use something like that in Sublime for a hot minute, but you know, it's a plugin. It's not. So it's a little wonk, but yeah, for it to be tied to the compiler, I really dig that. Okay, and then you can just scan for those things too. These expressions are very handy. Oh, sometimes when warnings have popped up during exercises in this book, we have told you to ignore them for the moment. Our goal was to minimize distraction and move on with the exercise. But when you are writing production code, you should not leave warnings unaddressed. Indeed, and even though a program with warnings will compile, to allow you to run and test your code. A warning means that there's probably a logic error in the program that will have runtime consequences. Since you are a conscientious programmer, you will never have unintended warnings hanging out in your code. The warning expression can be a useful tool to keep track of issues you know you need to fix. In chapter 23, you used a to-do comment for this purpose. Compiler warnings are a more in-your-face way to accomplish the same goal. Which you prefer is up to you. Yeah, I agree. It is very much in your face. They didn't tell us where the to-dos pop up, so I mean I'm just gonna roll with. Yeah, I mean I like the warnings better anyway, only because you can't escape it. Like eventually you got to build your app, and then you would see the warnings. Okay, so then plus these become like a cool orange color, and to-dos were like a lame gray color. So yeah, there's that. To do comment. Now update your store method to set a new change handler on the new asset. The change will introduce an error, which you will fix in the next step. Okay, so we need to go to the asset file. Asset, and you want me to self-container. Oh no, the store method. My bad. Which is in main, right? Nope. Where the hell is it? Oh, it's further down this file. No, it's not. Oh, there it is. Gosh. Okay. So the method store asset container. Okay, so right here, asset.change handler is equal to this closure so in this case the argument that we're passing is change in, and then the logic of our closure, so that is print and asset has changed value by, and then it'll show us the value, new total value, total value. So whatever that value is, it should print change and print. Yeah, so it should make the change and then also print our new total value. Also update your simulation to account for your coin appreciating in value. Oh, hot dog, okay. Our coin. Created some assets. So here you want it, brother, coin dot value increment operator 137. Try to build your program now. Okay. Yeah, come on, brother. Just you will get an error message reading reference to property total value enclosure requires explicit use of self to make capture semantics explicit. Reference to okay. By default, any variable or constant of reference type is a strong reference. Right, we just learned that. Closure captured references are no different, and the strong reference exists as long as the closure does. I see. Okay. Look again at the closure in store, which was in vault. Yeah. So here, look again at the closure. So this is our closure. Okay. At first glance, it appears that the closure only captures value types. Where is change? Where is that? I guess that could be anything. Oh yeah, because that's just what we would pass to it, the double. This could be Chan. Right, and then still the same error. Okay, yeah, so that's just whatever, doesn't really matter. It just needs to make sense relative to the context of the code, but that's not like a pre-existing variable somewhere or whatever. That's just the argument we're going to pass to it. Wait, but is that, hold on, make sure that's true. So the change, yeah, that's right. Okay, because it just handles the first. Yeah. Okay. All right. So as long as that closure by default, any variable or constant or reference type is a strong reference. Closure captured references. Yeah. First glance appears. At first glance, it appears that the closure only captures value types. Both change and total value are doubles. Right. Okay, I see it up top. Yeah, double. Okay. However, since the compiler cannot be sure that the value of a property like total value will not change after the closure is created, because it's a var, so because this is not a constant, it could change. So that's true. Not change after the closure is created. The closure instead captures the object that owns the property. However, since the compiler cannot be sure that the value of a property like total value will not change after the closure is created, the closure instead captures the object that owns the property so that it can access the property and read any fresh or computed value it may have. Okay, so not the value of the property itself. What is it called? Capturing. Okay, so it just captures the object because something else could change it because it's just a var and it's a reference type, so something else might change it. Okay. Since total value is a property on Vault, here, let me get rid of that. Which is the type of self within the scope of the closure. Container, what do you mean within the type? Oh, where we defined, yeah, so where's that at? An asset. What do you mean type of self? Hold on. Total value, type double. Since total value is a property on Vault, which is the type of self within the scope of the closure. What does that mean? So, since total value is a property on Vault, which is the type of self within the scope of the closure. Yeah, I really want to know what that means. Closer, a strong reference to the... Since the total value is a property on vault, which is the type of self within the scope of the closure, a strong reference to the vault instance itself is captured. Swift wants you to notice this capture, hence the error, by requiring you to explicitly reference self. Swift makes you consider whether you are creating a strong reference cycle, and therefore a memory leak. Fix the error. Okay. Yeah, maybe that'll help to just... Oh, literally just that. I'd still like to understand why, though. Okay, so it's... Oh, okay, okay. I think I get it. Total value is a double, but within the scope of the closure, which is here, we have to be explicit because the compiler cannot be sure the value of a property like total value will not change after the closure is created. Okay. Closure instead captures the object that owns the property. As in a reference? I don't know what that means. I'll ask, but I mean, yeah, that's the part that's kind of brain effing me right now. Captures all that owns the property so that it can access the property and read any fresh or computed value it may have. Or does it just mean it captures a reference to the entire, like, object as in the entire thing, the instance of vault? That's probably what it means. Since total value is a property on vault, which is the type of self within the scope of the closure. Yeah, rereading it for the 8th time more slowly didn't help. So I'm gonna just go ahead and consult the oracle there, brother. All right, now give me that code there, guy. Please explain the below excerpt. Specifically, why, or what is meant by saying closure captures the object and that owns the property. And what was the other thing? Since yeah, and also why the also why the self is required within the context of a closure. That should do it. All right. The explanation is about how closures handle capturing variables and the importance of understanding the capturing of self in the context of closures. Capturing variables and closures. When you create a closure in Swift, it can capture and store references to any constants and variables from the surrounding context in which the closure is defined. In our case, from within that asset class. Wait, right? That's where it was? Or sorry, within the vault class. Okay, and this process is known as capturing. Oh, so it's like its own thing. Okay. The closure can then access and modify these captured variables even after the context where they were defined has been destroyed. What? When you create a closure in Swift, it can capture, like, they're literally, so is it copying it or what? I don't understand that. And store references. It can capture and store, well, yeah, it is. It says it. And store references to any constants and variables from the surrounding context in which the closure is defined. But it's, whoa, what just happened? That was weird. This process known as capturing even after the context where they were defined has been destroyed. Capturing objects that own properties. In the specific example provided, so we have our store method here in the vault class. So nothing asset container equals self. Okay, yeah, that's just as we wrote it. Okay. Here, asset change handler is a closure that captures the change parameter and the total value property. Okay. Value types versus reference types. Value types, int, double struct, enum, and what's the other one? Oh no, it's there. Yeah, enum and struct. Yeah, int, double. When value types are captured by a closure, Swift captures a copy of these values. Int, double, and struct. Okay. In our case, total value, the thing that we're talking about, is of type double. Reference types class. When reference types are captured by a closure, Swift captures a reference to the instance. In this context, total value is a property of a vault object, which is a reference type. Okay. Oh, okay. Okay. So, okay. So not necessarily the property's value, but the object that owns its type, and that is a reference type. Okay. Yeesh. All right. Because the compiler cannot be sure if the value of total value will change after the closure is created, it captures a reference to the vault instance that owns total value. It captures a reference, but it's just a reference to the vault instance that owns total value. This ensures that any future access to total value within the closure will reflect the most up-to-date value. Captures a reference to the vault instance that owns total value, which is itself the vault type. I don't get how that helps if it's gone. How does it still do something with it if it's just a reference type? This ensures that any reference or any future access to total value within the closure will reflect the most up-to-date value. Why explicitly reference self? The self keyword in Swift refers to the current instance of the class where the code is being executed. In the closure, yeah, so that's odd. Okay, so self.total value, meaning, oh, so self.total value, self, because we need to know that we need to get into, that's where it was jacking me up, because I thought we were talking about the type double, but we're not. We're talking about the class, or sorry, the vault type that we created here. So self is like saying vault in that case, because it would be an instance of, wait, self dot, yeah, so self. Vault is equal to self, and then dot gets us to total value, so whatever that property is. Okay, so it always has to access it that way. So the type of the instance, which is whatever it is, and then you access the property. Okay, that makes sense. That makes sense, but clarity and intent. We'll finish reading this and then I'll ask it the next thing. The self keyword in Swift refers to the current instance of the class where the code is being executed. Yeah. In the closure, self.totalValue explicitly refers to the total value property of the vault instance. Yeah. All right. Swift requires you to use self explicitly in closures to make it clear that you're capturing self, the current instance. Yeah, okay. Because there could be multiple. Yeah. All right. No, that's good. That makes sense. This explicit requirement serves two primary purposes: clarity and intent. Yep. Avoiding strong reference cycles, memory leaks. Capturing self strongly within a closure can lead to strong. Capturing self strongly within a closure can lead to strong reference cycles. A strong reference cycle happens when two objects. By making the capture explicit, Swift encourages developers to think about the potential for such cycles and, when necessary, to use weak or unowned references to break the cycle. Okay, so they're forcing you to be explicit, but you still might have to add that weak keyword or unowned, which we haven't seen yet, but okay. In the store, property asset, So total value is a property itself. The closure captures self to ensure it can access the latest. Okay, let's read that because I didn't know if that would be applicable, but it sounds like it is. So in the store function, asset.container equals self sets the container property of the asset to the current instance self. Okay, we covered that earlier. And then asset.changeHandler is equal to this closure. So we pass in that as the argument. And then here's whatever the logic is. Assigns a closure to the changeHandler property of the asset. Yeah. Inside the closure, print an asset has changed. Since the total value is a property of self, the closure captures self to ensure it can access the latest value of total value whenever the closure is executed. The requirement to use self inside the closure makes the capture explicit. Yeah, but that's still not, it's really this part. It's strong reference. Swift wants you to notice. No, not that. I can't be sure. The closure instead captures the object that owns the property so that it can access the property and read. Okay, yeah, this part right here. So, I guess I don't even need to type that, but please expound on the portion where it states that the capture occurs. What does capturing actually entail from a syntax perspective and behaviorally that a app dev should understand. When we say that a closure captures variables, we mean that it takes a snapshot of the variable's values or references from the surrounding context where the closure is defined. Really? A snapshot, okay? This captured data is stored by the closure and can be used when the closure is executed, even if the original scope where the closure was defined no longer exists. What the fuck does that mean? What? I'm sorry, but it's a very triggering statement. What does that mean? Even if the original scope where it was defined no longer exists? Please clarify. Let's explore the syntax and behavior of capturing variables in Swift. Okay, great. Capturing value types. For value types like int, double, and structs, the closure captures and stores a copy of the value. Okay, yeah, I get that. But capturing reference types. For reference types, like instances and classes, which is what we're dealing with here, oh, instances of classes. Yeah. The closure captures a reference to the instance rather than a copy of its current state. Okay, I think part of the issue is I'm taking it's closure, even though I'm taking the original scope where the closure was defined no longer exists as deallocation, but maybe that's not the same thing. So hopefully this will clear that up. But for a reference type, the closure captures a reference to the instance rather than a copy. Okay. So just it's a pointer, not the actual value. The actual value is somewhere else in memory, in a singular place. Here, closure captures a reference to my object, class, my class, single property of value. We have a constant my object that's equal to an instance of my class, so this would have that single property value equal to 10. Then we say let closure equal, and then no argument, print my object.value. Okay, then we change the property. My object.value is 20. The closure prints the updated property value. Closure output 20. Here, closure captures a reference to my object. Here, a reference to my object. When the property value is changed to 20, the closure reflects this change because it holds a reference to my object. Okay. That doesn't explain the other thing, so we'll see what else they say. Capturing self enclosures. When a closure is defined within a class method, capturing a property of the class implicitly captures self in the instance of the class. To make this explicit, Swift requires using self dot within the closure. I get that part too. So that's in this vault example. Asset change handler is a closure that captures self. Total value property. Yeah, behavioral. This is, strong versus weak. Capturing self strongly can lead to strong reference cycles, which occur when two objects hold strong references to each other, preventing deallocation. To avoid this, use weak or unowned. Weak or unowned. var. Oh, so that would just change the... Oh, weird. Okay, but we haven't even got there yet. What does that one piece mean? If a weak capture... Yeah, all right, hold on. Let me find that other spot. Captures change to... Copy its current state. Okay, that takes a snapshot. Okay. Please expand on this. I am having trouble understanding. Stored by the closure can be used when the closure is executed, even if the original scope where the closure was defined no longer exists. Yeah. How this is possible if the original scope no longer exists, since we are reference type. Also, capture data is stored by the closure and can be used when the closure is executed. Also, when does the actual capture occur and where is it stored in relation to the instance? Also, should it be understood that the closure is created at the same time the instance? Scope and lifetimes. When a closure captures variables, it retains a reference to those variables even after the original scope where the closure was defined has exited. Okay, so they're saying that even after, like if we call store, this function, this closure runs, and then I can still access these values that I end up printing out, like self.totalValue, after it's done running. Maybe. I feel like we're getting a little closer, but no scope where the closure was defined has exited. This means the closure keeps alive the references to the objects it has captured. Okay. So it prints it out, but then even after that, it's done running, but it keeps alive the references. Yeah, I don't know what that means. Ensuring they remain in memory as long as the closure itself is still in use. But that's what I'm saying. You just said it exited. It just exited. Killing me, brother. Capturing reference types. When a closure captures a reference type, such as an instance of a class, it holds a strong reference to the object. When a closure captures a reference type, it holds a strong reference to the object. This means that the object will not be deallocated as long as the closure is alive, because the closure's reference counts as a strong reference that contributes to the object's retained count. This means that the object will not be deallocated Okay. When does the capture occur? The capture happens at the moment the closure is created. At this point, Swift takes a snapshot of the references to the variables within the closure's surrounding context. These captured references are then stored within the closure itself. Example to illustrate. Okay, thank you. Here's our class vault. Total value, type double. We start with the value 0.0. Here's our method, very similar to the one we had. In signature, this is the same. Change handler, this is different with the weak self, but other than that, change. And we added this guard statement. Guard let self equal self, else just return. Okay, so none of this should affect the capturing behavior. Okay, so the closure asset change handler captures self at the time the store method is called. Okay, so the method gets called. And when it gets called, self, which would be the instance of a vault, is captured, meaning we have the current value. It may be 0.0, it could be something else. Okay, so, but not a copy, a reference to it, to the instance. I think it's starting to click. Okay, so we store it's in memory somewhere, even if it is a reference type. It's just a singular point in memory. But if we capture, and by capture we mean we increment the reference count to it up by 1, then even after the closure exits, that means the instance of vault would still have a reference count of 1. And by definition, if it has a reference count greater than 0, it will remain in memory, therefore the old value will be there. Hot dog. All right, well, I got there eventually. Whew, okay, let me save this. The closure asset change handler captures self at the time. Yeah. If self were captured strongly without weak self, the vault instance would remain in memory as long as asset. Okay, yeah. The capture data references are stored inside the closure itself. The closure maintains these references internally, which ensures that the objects are kept alive for as long as the closure can be executed. So the references, maybe that's the difference too, is normally the references would be inside the instance of vault, but they're saying in this case it's stored inside the closure itself. The reference is whatever that is, the pointer. Maybe we'll ask. Store. The closure maintains these references internally, which ensures that the objects are kept alive for as long as the closure can be executed. Relation between closure creation and instance creation. The closure is not necessarily created at the same time the instance is created. The closure is created at the moment the code defining the closure is executed. Okay, that makes sense. Yeah, they did tell us that before. All right. Detailed explanation with an example. Oh, I thought that was a detailed explanation. Okay. Total. Change handler, closure creation. All right, original scope exit. Even if the store method returns and the local scope of store is exited, the closure retains its captured references. Yeah, so I just didn't understand that the closure itself is like its own bucket. The closure execution. Later, when asset change handler 10 is called, the closure executes and accesses self total value. Oh, because it would have set, I got hot dog. Okay, so then it uses a weak reference. Memory management. Okay, so then two questions. First one. So, are you saying that because, or no, wait. So then assuming we do not use the explicit weak self, the closure is keeping self alive by virtue of incrementing its reference count by 1, which in turn means that we can assume the variable will remain in memory with the newly updated, what's the property name? Value, total value. Which in turn means that we can assume that the variable will remain in memory with the newly updated total value that the closure just printed inside a string. Is that correct? All right, hot dog. Okay. Yeesh. All right, so then, great. So my only other question is not entirely important, but I just want to understand. Man, this thing is chatty. Okay, so, still going. As an aside, when you say the capture is, or yeah, when you say the capture occurs within the closure itself, what is that in contrast to? Would it otherwise be captured within the, what would you call it? The class instance itself? And if so, is it appropriate to think of the closure store Is that what it's called? Store. Yeah, store as an isolated bucket inside the class instance bucket. Capturing within the closure. When we say that a variable or self is captured within the closure, we mean that the closure retains references to the variables from its surrounding scope. These retained references are stored inside the closure's internal structure, not within the class itself. Oh, so it's not, okay, it's not even, it's written that way, but that's not how it works, I guess. Closure versus class. Closure. A closure is a self-contained block of functionality that can capture and store references to any constants and variables from its surrounding context. These references are stored within the closure's internal data structures. Okay, so they're more standalone than I initially understood. Okay, so then class instance. A class instance is an object that holds properties and methods. The instance itself does not inherently capture variables from closures. Instead, it provides the context in which closures may capture its properties. Consider the following class and closure. Vault, class vault. Okay, this is it's our same code. Okay, when the closure is defined inside store, it captures self, the vault instance, right? Captured references. The closure retains a reference to self inside its own internal data structure. Yeah. This captured reference allows the closure to access self.totalValue even after the store method has returned. Even after it's returned. So it's, okay, I always thought it was like it runs once it returns and then it's gone. But apparently it can run, return, and then hold on to stuff. The closure itself. Isolated bucket. Your analogy of the closure as an isolated bucket inside the class instance bucket is partially correct, but needs some refinement. Okay. Closure as a container. Think of the closure as a separate container that retains references to variables and objects it captures. Okay, so not inside of, but separate. These references are not stored in the class instance, but within the closure's internal structure. Class instance providing context. The class instance provides the context and variables that the closure can capture. However, once captured, these references live inside the closure, not the class instance. Let's visualize it. Class, instance, vault. Properties, total value, assets, methods, store. Closure within store. Captures self, references vault instance, retains this reference internally. Vault instance, total value, assets, store method, closure. The vault instance has provided properties and a method. Yeah, the store method defines a closure. The closure captures self and retains this reference within its own internal data structure. Okay, captured references location. The closure retains captured references within its own internal data structure, class instance, and closure relationship. This is, okay, yeah. The class instance provides the context for the closure, but once the closure captures variables, these are retained within the closure itself. It's appropriate to think of the closure as a separate container or bucket that retains references independently of the class instance. Yeah, that's surprising. Okay, that was really my hang up. Okay. It retains references independently of the class instance, even though the class instance provides the context. This understanding helps in grasping how closure is managed. Okay, but Okay. But is it correct that the closure is only storing references and therefore without the instance of the class continuing to exist in memory, the closures references would be useless, and so the main, I'll suppose, and so the behavior of the closure capturing the reference and at the same time incrementing the reference count to the class instance, and so the behavior of the closure capturing the reference and at the same time incrementing the reference count to the class instance is necessary. Finally, okay. All right. Yeah, and I get, I mean, the way it's described a lot of times, I mean, obviously it's not malicious, but there's some stuff that's skipped in terms of like how they're describing it, which I suppose we don't have to dig into it. I mean, we could just like, okay, that's how it works. But yeah, okay. So all right. Oh man. Okay. Okay, well, it says, yes, you are correct. It's important that I read that out loud. Yes, you are correct. Thanks, AI. Let's clarify this further with a focus on the importance of reference counting and how closures interact with class instances. It remains strong reference to that instance. Okay, I think we get that part. So, all right, yeah, let me save this and then, yeah, oof, that was a doozy. But glad we got through it, and now it makes sense. And let's throw that bad boy over here. Memory management, closures capturing reference types and how they hold onto value. References to values. Okay, so phew. All right, so we will definitely wrap it up there for today. What a do's. But I felt it was fruitful. So thanks, guys, for tuning in. We'll be back tomorrow, same time per usual. Make sure you drop a follow and all that other good stuff. Just comment anything. Google guy helps me out. It's free for you, brother. Come on, don't be stingy. No, I'm just kidding. But otherwise, hope you guys have a good day, and also make sure you check in same channel 9 p.m. Central every single day, unless said otherwise, where I'm running my other stream, 100 Days of Halo Infinite. Tonight is day 64, Road to Onyx, and we are currently I'm struggling bouncing between Platinum 6 and Diamond. So at any given moment, currently I'm 6 or 7 tiers away from my goal. So I think we still have enough time. Come check me out if that sounds cool. Otherwise, I'll see you guys tomorrow. Take care of yourselves. Have a good day.